Hello, everyone, and welcome to Exponents and Radicals Lesson 6. So now we are going to jump into some rational exponents. And we're going to start by reviewing the exponent laws. I want to go pretty quick through this. Hopefully you know what's going on, and you remember some of this from grade 10. And if not, we can go over a longer example or a longer review in class. But this is a longer video, so I want to just get through this pretty quickly. So the exponent laws, I think you learned this definitely in grade 10, quite possibly in grade 9. I can't really remember, but the first one is the product law. So what I like to do is jump over to this side here and look at the numerical example. I think it makes the most sense. So you can see here, when we have 8 to the power of 3 multiplied by 8 to the power of 2, it becomes 8 to the power of 5. When you multiply exponents with the same base, right, the base of the exponent there is 8, the exponent is 3. The next one is base 8, exponent 2. You end up adding the exponents. 3 plus 2 is 5. So in this case, a to the power of m multiplied by a to the power of n would be a to the power of m times n. That's a multiply sign. My dot's not very big. There we go. That's the product law. So powers of the same base. When you multiply, you add exponents. And then the quotient law is dividing. So when you are dividing numbers with the same, or exponents with the same base, so you can see here we have 8 to the power of 3 divided by 8 to the power of 2. Same question, except we're dividing this time. You end up subtracting the exponents. 3 subtract 2 is 1, so 8 to the power of 1. Or we can write that as just 8. 8 to the power of 3 minus 2. And the reason that is because in the top we have 8 to the power of 3, and in the bottom of the fraction we have 8 to the power of 2, or 8 times 8 times 8 divided by 8 times 8. And those end up canceling out. So all you're left with is 1 8 on the top. So a to the power of m divided by a to the power of n is equal to a to the power of m divided by a to the power of n. So that would be a to the power of m minus n. So hopefully those ones make sense. Those ones are the most common ones. We have power of a product law. So in this case, when you have two terms multiply by each other, making up your base, that means that this whole base is still just one term. That 3 acts on both of those. So that becomes, or that exponent 3 acts on both of those. So that becomes 8 to the power of 3 multiplied by 8 to the power of 7. And you have to be really careful. That only works if the base is one term and it's multiplying. If you have, for example, you did this a lot last year, x plus 2 to the power of 2, you cannot just factor that 2 in and say, ooh, look, x squared plus 2 squared. That doesn't work. Your base here has two terms, right? You have your x term and your 2 term. They're like adding together, so they're two separate terms. So that actually becomes x plus 2 multiplied by x plus 2. It's the base multiplied by itself twice. We won't really get into that in this unit, but we will be doing it in a few units. It's important to remember that this power of a product law right here only works when the entire base is one term or it's all multiplied by each other. So that becomes, didn't switch, a to the power of m multiplied by b to the power of m. All right, same thing with power of a quotient law. It's the same idea, but now your base is a fraction or it's two terms divided by each other. So you can see here that we have 8 over 7 all to the power of 3, and that becomes 8 to the power of 3 over 7 to the power of 3. That 3 ends up acting on both numbers. So a over b to the power of n is going to be a to the power of n over b to the power of n. I've got my computer set up differently now, so I'm hoping to touch the screen less, but I think it's making my writing a little bit messier, so something I'll have to get used to. And power of a power law. When you have an exponent to an exponent, like 8 to the power of 3 all to the power of 2, you end up multiplying your exponents. 3 times 2 is 6, so that whole thing is 8 to the power of 6. So 8 to the power of m all to the power of n is going to be 8 to the power of m times n. People get this one mixed up with the product law, right? So it's different than having, wait, hang on, I might be able to, oh, see, it's already messing up. Let's get this keyboard out of the way. People get this power of a power law mixed up with the product law. So just remember, it's different if it's 8 to the power of 3. Oh, this might not work. Okay, let's put the keyboard back on. Sorry, I know it's going to be a long video, and here I am messing around. If you have 8 to the power of 3 multiplied by 8 to the power of 2, that is when you add them. Two exponents with the same base is 8 to the power of 5. But in this case right here, you only have one base and two exponents, so you end up multiplying them. So just be careful. A lot of people get those confused. We are going to be using some of these power laws or exponent laws coming up, so I just wanted to review that quickly. And now we're going to look at exponents that are in fraction form. So first we're going to start with a little bit of investigation. So if we have root 5 multiplied by root 5, we know that we can write that as the square root of 25, and then we know that the square root of 25 is just 5. So root 5 multiplied by root 5 is just equal to 5. And we can do the same investigation with 5 to the power of 1/2 multiplied by 5 to the power of 1/2. So exponents with the same base means we're going to add those. Maybe what I should do is zoom it in a little bit. There we go. We are going to add those exponents, right? Powers of the same base. We add the exponents. 1/2 plus 1/2 is basically like 5 to the power of 1, which is just 5. So we can say 5 to the power of 1/2 times 5 to the power of 1/2 is also just equal to 5. So knowing that, we can also say that 5 to the power of 1/2 is equal to root 5, right? And that's exactly what it's saying, is root 5 is equal to 5 to the power of 1/2. It's the same thing, means the same thing. And so we can do the same idea with cube roots as well. The cube root of 2 times the cube root of 2 times the cube root of 2 is the cube root of 8, which reduces to 2. And then 2 to the power of 1/3 times 2 to the power of 1/3 times 2 to the power of 1/3. When you add all those exponents together, you end up getting 2 to the power of 1, right? 1/3 plus 1/3 plus 1/3 is 3/3 or just 1. So 2 to the power of 1/3 is the same as the cube root of 2. It's the same thing. So you can see that the bottom of the fraction becomes the index, right? The bottom of the fraction becomes the index. So we can do a couple of example questions. Write the following in radical form. So we know that the root is the bottom of the fraction. So this is going to be the square root of 25. The root is the bottom of the fraction, so this is going to be, or the index is the bottom of the fraction, sorry. So this will be cubed root of 64, that 3 coming from the bottom of the fraction there. In the next case, we have the 81 to the power of 1/4, so our index is the bottom of that fraction. So now we have the 4th root of 81. It's the same thing. It says verify with your calculator. You can totally do that. You can also take these one step further if you want. The square root of 25 is 5. The cube root of 64 is 4. And the fourth root, or 81 to the power of 1 over 4, is 3. You can do this with variables as well. This would be x to the power of 1/2 is going to be root x. B to the power of 1/3 is going to be the cube root of b. P to the power of 1 over 10 is going to be the 10th root of p. And a to the power of 1 over n will be the nth root of a. Yay! We're doing it. Investigating the meaning of a to the power of m over n. So now what we're going to do is we're going to have a numerator in our exponent. So up until this point, we've been looking at, for example, 5 to the power of 1/2 or 2 to the power of 1/3. So our numerator has always been 1, but now we're going to look at what happens if it's not 1. What do we do? So root 5 to the power of 3 times root 5 to the power of 3 is just the same as 5 to the power of 3. And that is also 125. 5 to the power of 3 over 2 times 5 to the power of 3 over 2 is going to be, well, we're going to add those exponents. 3 over 2 plus 3 over 2 is going to be 6 over 2. And 6 divided by 2 is like 5 to the power of 3, which is also 125. So can we say that the square root of 5 to the power of 3 is equal to 5 to the power of 3 over 2? So the square root of 5 to the power of 3 is the same as 3 over 2. My high school teacher always taught me flower power. I know that sounds weird. It reminds me of Mario because you get the flower in Mario and then you've got like the fireballs you can shoot. But the reason she taught me this, and it actually sticks with me, is because if we have 3 over 2, if you imagine this fraction here, this exponent fraction, to be a flower, let's see, you have your nice flower here in the top, but the bottom actually is roots, right? If that's the ground. So those are your roots. So this is how you remember that the bottom of the fraction is the index of your root, and the top is the power or the exponent. So flower power. Flowers on the top, the roots on the bottom. That's how flowers grow. So if we take this and we say, well, we have 2 multiplied by the root, or 2 to the power of 2 over 3. Well, the bottom is my root sign, so I can say that's cubed root because the bottom is the root. And then we have 2 to the power of the top, 2 to the power of 2. So those are equal to each other. Flower power. Hopefully you remember that. So write the following in radical form. Well, we have x to the power of 5 over 3. So we can rewrite that as the third root of x to the power of 5, right? The 5 being the flower or the power and 3 being the root. Same thing with b to the power of 4 over 5. Well, that's going to be the 5th root of b to the power of 4. And the last one, p to the power of 5 over 2. So that'll be the square root. We don't have to write the 2 because it's always assumed. And then the square root of p to the power of 5. Power root. Done. Hopefully you remember that. It says here, evaluate We're going to just skip that, actually. We're going to do some exponents. We're going to do some examples, sorry. So we have, it says write the following in radical form and evaluate. So what we can do is evaluate manually. I think it means without a calculator, and then we're going to verify with the calculator. Either way, you'll be fine. If you do it with or without the calculator, I'm going to be happy. So we can rewrite this as the square root of 64. And then we can either say, it's all to the power of 3. So the square root of 64 is just 8 to the power of 3. And 8 to the power of 3 is 8 times 8 times 8, which is 512. 4 to the power of 5 over 2 is the same as square root of 4 all to the power of 5. The square root of 4 is 2 to the power of 5, which is 2 times 2 times 2 times 2 times 2, which gives you 32. And then 81 multiplied by 3, or 81 to the power of 3 divided by 4 is the same as the fourth root of 81 all cubed. The fourth root of 81, this one's a little bit trickier. That is 3 to the power of 3, which is 27. Awesome. I hope that you're starting to pick this up a little bit. So here is kind of a synopsis of what's going on. This is what we just talked about right here. So a to the power of m over n is the same as and the nth root of a all to the power of m. Those are kind of that's the law that we just looked at. And then it actually works for negative exponents as well. If we have a negative fraction exponent or negative rational exponent, we know with negative exponents, if you have x to the power of -2, you end up flipping that expression to make that exponent happy or positive. So x to the power of -2 is equal to 1 over x to the power of 2, and that's how you switch that negative exponent into a positive. So you can do the same thing down here. A to the power of -m over n can be written, they don't really show you that intermediate step, but that's okay. A to the power of -m over n can be written as 1 over a to the power of m over n. To make that exponent happy, you flip flip that fraction, and then you can rewrite that as the nth root of a all to the power of m. And that's how they get from this to this. But that's okay. I think as long as you know that, you're good to go. So write the following in radical form and evaluate without using a calculator, and then verify with a calculator. If you need to use your calculator, that's totally okay. So 25 all to the power of 3 over 2 is the same as the square root of 25 all to the power of 3. And we know the square root of 25 is just 5 to the power of 3, which is 125. Hopefully that makes sense. Let's do every second one. 27 to the power of -2 over 3 is the same as 1 over 27 to the power of 2 over 3, which is 1 over the third root of 27 all squared. And we know the third root of 27 is going to be 3, and it's still squared, and 3 squared is 9, so our answer becomes 1 over 9. We then have -8 to the power of 2 over 3. 3 is the root, and we're allowed to take the cubed root of negative numbers. So what we can do is we can convert that to the cube root of negative 8 all to the power of 2. And we leave that negative inside here, or under the cube root sign. The cube root of negative 8 is just negative 2, and it's still squared. So when we do that, we get positive 4. In this case, you can see that negative isn't part of our base. So in the first one, the exponent here acted on this entire base because there was a fraction, or there was brackets there grabbing all of it. But in this case, this exponent here only acts on the 8 as the base. So now you're going to leave it outside. You're going to say negative root of 3 and then 8 all to the power of 2. So, sorry, the third root of 8 all to the power of 2. So now you can evaluate. Keep that negative on the outside. The cube root of 8 is just 2 squared. 2 squared is 4. So you can see it actually makes a difference in your answer. If that negative is part of the base, then the answer is going to be different than if the negative isn't part of the base, right? Part of the base, sorry. One's positive 4, one's negative 4. And the last one that we will do is 3 squared plus 4 squared all to the power of 1/2. So you can say 3 squared is 9 plus 4 squared is 16 all to the power of 1/2. And then 9 plus 16 is 25 all to the power of 1/2, which is the same as the square root of 25, which is just 5. Awesome. You can do this with fractions as well. Maybe I'll do one fraction. Oh, I didn't scan that part of it. Maybe we'll do that in class then. In class, we will look at fraction bases. Cool. Thanks for watching and have a great day.